Alright, gentlemen, this is going to be the start of our flipped classroom experience. I hope to have already kind of described what we're going to do, but you guys are going to take notes alongside the video so that we can compare when we're done the notes that I'm going to take and make sure that we're all on the same page, what my expectations are for you guys, and what I want you to gain from these videos. So what we're going to talk about today is the parent functions, and as you can see next to this family, I have our constant, linear, absolute value, and quadratic. So these are going to be the functions that we're going to talk about today, and then a little bit of translations with them. So these functions are going to have some sort of rule attached with them. Some sort of rule. So we're going to have f of x, function of x is going to equal a constant number. So in this case, we're just going to say our constant is 1. Now what this is going to look like on our graph, it's just going to look like a straight line. No matter what x we put in, our y value is always 1. So let's actually grab a different color for this. So no matter what, our x value is always 1. Now the domain of this, if you remember the domain, I'm going to write in parentheses, this is like kind of our x value, and our ranges are all of our y values. So the domain is going to be all the reals. All the real numbers. Or you can be fancy and write a r like this. So it's going to have like two of these vertical lines here. It's going to have two of those. We might get into that a little bit later. And then our range is the y value. So what y values does this contain? Well, it's only the y value of 1. Linear, it's a line. So our function of x is going to contain something with x. And if we draw this exact function, it's going to look like this. So whatever your x value input is also going to be our output. So when it comes to the domain, we are also going to have all the reals, and the range is also going to be all the reals. If you remember what the absolute value is, f of x is equal to the absolute value, denoted by these vertical lines. Get something that looks like this. So you remember, quick refresher on absolute value, you basically make the item non-negative. So if I have 2, the absolute value of 2 is just 2, but the absolute value of negative 2 is positive 2. So absolute value more talks about a distance that you are from 0. The distance from negative 2 to 0 is 2. So that's kind of how I'm going to have you guys think about this. Now, as you can see with the x's, our domain is still going to be all the reals, but in this case, the y's, with the parent function, it's always going to be greater than or equal to 0. You never see anything on the bottom side. And lastly, our quadratic is going to be something of the form of x squared, and it's going to look like a parabola. Let's move this down so it actually touches 0. So it's going to be our parent functions. Once again, this is going to touch all of the x values, but once again, our range is going to be y is greater than 0. Talking about translations, this is how we're going to move these sort of functions around. If I add things, if I subtract things, if I make things steeper, if I make things, go up faster or down slower, this is what it is all going to look like. So we're going to start with looking at what does 2 times the absolute value of x look like. So if we make ourselves a little chart here, and we have our x input, we have our parent function y is equal to the absolute value of x, and then we have the function that we're dealing with, our g of x right here. Let's just pick some numbers, and then look at what the results are going to be. So if you think about absolute value, it's just going to be the positive version of all these. So we're just going to have 2, 1, 0, 1, 2. And then so what happens with this 2? We're just going to multiply the absolute value of x, which is coincidentally all this stuff, by 2. So the absolute value of -2 times 2 will be 4. Absolute value of -1 multiplied by 2 is 2, 0, 2, 4. So this shouldn't be anything too new and exciting, but we could go over this if we need that extra bump. So let's draw our parent function. So this is our parent function, and then our new function. So at -2, just call over here, we're going to be at 4, so we're going to be all the way up here. And each side of these functions are linear, so we could just draw a straight line. It's the same deal over here. So we could say this is 4, and around here is 2. So that's going to be what that is, and how we kind of deal with that. I suggest that you make this table when we're dealing with these until you get really good at it. And let's move on to 1/2 x squared. So I'm going to make our same type of table. Y is equal to x squared, and then y is equal to 1/2 x squared. And we're going to keep on going. We're going to use our same numbers. Oops. So if we square something, we know we're going -2 times -2, which is 4, 1, 0, 1, 4. And now if we're taking half of that, we're just multiplying our x squared by 1/2. We could just take all these numbers and multiply them by 1/2. So we're going to have 2, 1/2, 0, 1/2, and 2. Let's go ahead and draw another grid. We'll have our parent function in black. So now at -2 we're at 4, but now with our new function we're going to be at 2. So it's going to be a little bit less steep. If we're calling this -2, this 2, 1, -1, probably about here, here, there, and there. So a little bit something like this. A little bit wider. This is not entirely to scale. This is 2, and maybe this is 4. But you get the point. When we're doing this on graph paper, we'll get a better, more perfect kind of alignment of what's going on.